Hey, what's up mga ka-food tech? Welcome again to another edition of Food Physics Mid-Year. So, I'm recording this sa araw ng sauna kaya may suot akong ganito. Wala lang. Well, maybe you've been wondering, we've discussed electrical properties and we've discussed magnetic properties. Ano kaya ang diferensya ng electromagnetic properties sa kanila? So, as usual, um, listen on to find out. So in magnetic properties, usually may kinalaman po siya sa magnetic field, whether it's induced by electricity or something from magnetic materials. On the other hand, when we talked about electrical properties, usually yung mga may kinalaman sa current flow. Now, when we talk about electromagnetic properties, it's actually based on electromagnetic waves, no? So visible light is an electromagnetic wave, and so is pretty much everything else. Gamma rays, X-rays, UV rays, infrared rays, microwave, radio waves, and other long waves. Okay? So, yung mga pinsan ng ilaw at mga kamag-anak niya, yun ang saklaw ng electromagnetism. So, when we say electromagnetic properties, therefore, these are properties determining the response rate of materials to either the absorption of or emission of electromagnetic radiation. Alright, so medyo hindi naman siya talaga overlap sa magnetic and electric properties, no? Concept that's important for us to remember is electric polarization. So if you recall, polar molecules are those like water which have an apparent charge because of the covalent bonds, so to speak, not canceling each other out. So for example, yung itong ating water ay pinaka-common natin na example ng isang polar molecule, whereas hydrocarbons like let's say CH4 is an example of your nonpolar molecule. So when you have a polar molecule, you have this permanent dipole dahil meron nga siyang parang apparent charge. And when you expose this to an electric field, yung normally randomly oriented na permanent dipoles ay suddenly mag-orient doon sa direction ng magnetic field, ng electric field natin. So that is what you call orientation polarization. On the other hand, if you have hydrocarbons which normally don't have dipoles, they will acquire temporary dipoles once you expose them to an electric field through electromagnetic radiation. Alright, and although it also aligns with the electric field, this polarization is lost upon removing that electric field exposure. So here's a video that you could watch. Forgive the Indian accent, no, but it does a good job of explaining electric polarization in brief, as well as providing graphic illustrations that are useful, especially for those of us who are visual learners. Okay, ayun naman ang katakot-takot na equation. So again, this is just to show us what factors affect electric polarization. And of course, that would depend on the strength of the electric field, all right, E, as well as it being a comparison of relation of polarization to an empty space or vacuum. So this is actually, again, sort of speak relative to polarization in vacuum. And then there are also factors which are dependent on the material. So obviously, if you have a different material, you would have a different value for polarization. Okay. Okay, so let's look at how that plays out. If you have a higher polarization potential as a material, you will absorb more amounts of energy from exposure to an electric field. And if that electric field oscillates or alternates periodically, so the molecule will also oscillate. And when the molecule oscillate, so the energy absorbed is released as frictional heat from your dipole reversal or reversal of the orientation or direction of your dipole, and that heat released is absorbed by the material, thus causing an increase in temperature. So if you were to look at the microwave oven, in a nutshell, this is what happens. No, kaya nga yung microwaves, di ba, parang ang sabi, they heat the water molecules or the polar molecules, and therefore if you have non-polar molecules in your microwave, they will not be directly um, affected as much by electric polarization. Kaya parang mas umiinit yung tubig or yung mga polar substances mo during microwaving, and parang hindi masyadong umiinit yung ibang bagay. So you can watch this short clip on how microwave ovens work and in practical na issues that you may encounter when using your home microwave oven system. Alright, so yung total polarization ng isang material is dependent on its total polarization potential, alpha, total, the particles concentration, and the electric field. So, and as we have seen earlier, yung total polarization potential is dependent on the permanent and the induced polarization. Okay, so and then the permanent polarization is dependent on the molecular dipole moment, Boltzmann constant, and the temperature. So there's a temperature dependence to the permanent polarization. On the other hand, the induced polarization is a tabular value, a property of na material specific. Okay, so we take note that the orientation of permanent molecules is impeded by their thermal movement, such that again, the higher the temperature, since as a denominator siya, there is lower polarization. Okay, so this table shows the dipole moments and polarization potentials of some simple molecules. So take note that nonpolar molecules have zero dipole moment, but they can be induced. Okay, so if you want to, you could try substituting these values in the equation to look at the comparable polarization values at fixed N and E, if you may, okay, and see what values you get. Okay, so again here, even if you have enough symbols to constitute a nightmare, so what we just want to point out is that these are derivations for presenting polarization potential based on either volume, mole, or mass. Hence, in each of the cases of psi, nakita mo lang na yung denominator niya is volume, mole, and mass respectively. So each equation, of course, will be useful in specific cases depending on what the givens are. But again, we will not be looking into this from a calculation perspective, as these are here to build up on concepts such as in explaining the temperature dependency of polarization. So take note, however, that the volume-based polarization potential size of capital N is actually dimensionless, because the numerator and denominator are both units of volume. Right, so one of the uses of the derivations we had in the previous slide is to lead up to um, being able to explore the temperature dependency of our mass-based polarization potential. So taking on the equation from the previous slide and doing the multiplication and substitutions, so we get this equation wherein if we multiply both sides and we look at which are the constants and which are the things that could change, we now have a slope-intercept form of the equation when equated to 1 over t. So as you can see here, there is a linear relationship with 1 over temperature in your x-axis and the mass-based polarization potential on the y-axis. So what this simply means is that for any given material situation, the mass-based polarization potential is directly proportional to 1 over temperature, which when you look at 1 over T means as the temperature increases or 1 over T decreases, bababa yung polarization potential. Okay. So ito naman pagdating sa frequency dependency of our alpha, yung polarization potential natin would somewhat decrease with increasing frequency. As you can see here, frequency of course refers to the frequency of the electromagnetic waves, no? So why does that happen? Because at a very high frequency such as 10 raised to 12 hertz, it would be too fast for rotational motion to occur on permanent dipoles, and thus in a way maybe wala na yung rotational motion since different types of molecular motion exist. Hindi lang rotation, but there's also translation and oscillation. Alright, so simply put, kaya parang mas ideal gamitin yung mga those on the slightly lower frequency na electromagnetic waves for, in this case, if we're gonna heat yung molecules mo for polarization because simply put, very dependent doon sa frequency ng electromagnetic wave yung ating lalabas na polarization potential ng material. So when we are dealing with optical frequencies, aka visible light, there is no polarization of dipoles, and absorption is caused only by electrons in the material, which are located in the chemical bonds in the electron clouds. Hence, in this case, the polarization potential could then be determined by determining the n, which is the refractive index of the material, which is an optical property. Okay, so this of course applies when we are dealing with optical frequencies of visible light. Okay, so when it comes to the electromagnetic spectrum, we know na ang isang wavelength ay may katumbas na frequency, and one of the best ways to visualize this maybe is to visualize the size of the wavelength. Okay, so for example, gamma rays, these are the highest frequencies and therefore the shortest wavelengths around the size of an atomic nucleus. And then between X-rays and UV rays are around the size of the electron orbit in an atom. So we know, of course, that the size of the wavelength definitely affects what it can do. Okay, yung around the size of UV, IR, and visible light, yung wavelength is around the size of viruses and bacterial cells. Then we might be familiar with itong EHF, UHF, VHF. So ito ay mga nasa airwaves natin, no? Yung mga channel sa TV, for example, is UHF. So apparently their wavelengths are around 10 to the minus 3 up to sa VHF around 1 meter. Okay. Other radio waves and short waves around the size of a house at 10 meters. Medium waves are around the size of skyscrapers. And very long waves could have wavelengths as large as the diameter of the Earth. So grabe yung electromagnetic spectrum na cover niya mula what subatomic particles up until kasi laki na ng planeta. So ganun kalawak yung radio waves, and obviously we have to select certain wavelengths for certain applications. Alright, so despite this chapter being named as electromagnetic properties, we will actually be focusing on one type of electromagnetic wave, which is the microwave. Of course, yung optical properties will deal with electromagnetic waves in the visible spectrum, and then your nuclear properties will deal with the higher frequency waves, no, such as yung mga gamma rays, etc. So anyway, microwaves are those with frequency ranging from 300 megahertz to 300 gigahertz. Okay. And other than the use for heating food, it's regulated in use for transmitting information for navigation, telecommunication, and medical purposes. And that is why, di ba, usually, pag electromagnetic wave yung form of transmission mo, minsan nakaka-form ng interferences. So, as in terms of interferences, can also be scattered or guided with the use of metal deflectors and reflectors. Okay, so to redirect the waves to a certain direction or concentrate them towards something. Similar to how, di ba kung iba sa inyo may mga satellite or cable something TV, merong parang satellite dish dun sa labas, and we know that those are used to concentrate the received waves to a certain location na mag-receive ng signals na yun. Alright. Again, one property of microwaves that sets it apart is the essential transparency towards glass, ceramics, and plastic polymers, since, as we have discussed, only polar molecules are heated up by microwaves. So in that regard, these transparent materials may likely not display any sort of polar kung may induced polarization man sila, ay very negligible ito. Alright, so recall that the speed of light is equal to the product of wavelength and frequency. So to get the equivalent wavelength or frequency, you just divide the speed of light by the other parameter. And recall that the relative permittivity of the material is the ratio between the electric displacement field divided by the same electric displacement field if it was in a vacuum. Okay, so trivia lang, no? If napansin niyo yung range ng frequencies for microwaves, pasok doon yung frequency ng transmission ng Wi-Fi. And yeah, even this wireless mouse I'm holding is 2.4 gigahertz. So apparently, microwaves may be able to interfere with the operation of your Wi-Fi, wireless transmission, and the likes, no? Although sufficiently shielded naman yung microwave oven supposedly, ay kaunti lang yung leakage nito, but I was able to find online about a person saying na pag ino-on niya yung microwave niya ay lumalabo yung reception ng kanyang headphones or something. Anyway, all right. So we've tackled this a bit before, but again, how is heat conversion done in microwave? So you can again watch the video on the earlier part of the slides if you want. So when you have electric dipoles exposed to the electric field of microwave radiation, oscillation occurs, and this oscillation of the molecules translate into kinetic energy, friction, and therefore thermal energy or heat. Okay, and the heat released is absorbed by the surrounding materials, thus raising the material temperature. Again, we're here dito sa concept ng permittivity. So, if we look at permittivity, there is what they call an elastic and inelastic component. Alright? Okay, so dito na naman tayo sa realm ng imaginary numbers. So, the complex relative permittivity epsilon asterisk is composed of the real relative permittivity epsilon prime plus the imaginary number multiplied by epsilon double prime, which is the imaginary relative permittivity. Okay, and the relationship of the epsilon prime and epsilon double prime is as follows. So the importance of the epsilon double prime or the dissipation factor is simply that ito yung magiging determinant mo dun sa food material as to how much power is being dissipated. Okay, so the higher this is, the higher the dissipated power in watts. No, parang how much power is actually being transferred into the food. Okay, assuming of course that the other factors are constant. As you may have noticed with most radio waves, there is a penetrating depth where it's trying to get a signal for your mobile phone or your television or whatever, even your Wi-Fi, di ba? Parang pag may harang dun sa pagitan ng receiver and sender ng waves, of course, merong pagbawas sa penetration. And we note, of course, that the longer wavelengths can penetrate more or travel longer distances compared to the shorter wavelengths. So the microwaves, when they penetrate into a material, dahil na-absorb ng dipole yung energy, nababawasan yung microwave energy and therefore nagwi-weaken siya. So we call the degree of microwave absorption as attenuation. And when there is higher attenuation, there is lower penetration depth because of course microwave is absorbed more readily by the material and therefore there is less energy in the wave to propagate. And if you look at this equation, so for example, to calculate how much power is left in the wave, of course there's the initial power niya nung pag-transmit sa microwave multiplied by this factor, e raised to the minus z over d. So, paano natin gagamitin ito? For any depth d, if you have a given microwave power output initially, you can compute for at that depth into the food how much na lang yung power na natitira, no? So and that can be computed if you compute for z, which is given by this equation. So naka dependent sa epsilon prime, and then yung tangent delta can be computed by the ratio of epsilon prime and epsilon double prime as seen in the previous slide. Okay, yung tinatawag nating loss angle delta. Alright, so as an example, if your z calculated is equal to the depth you are computing, then that means the ratio of your p to the initial power is equal to e raised to negative 1 or 36.8% of the original power na lang. Okay? So, yun yung importance ng z. No? Kasi z would determine um, how fast the the power lessens for increasing depth. So even though sinasabi natin at microwaves heat from the inside out, the reason why we still have a cold point, practically speaking, is because oo, iniinit mo yung molecule sa loob pero may penetration pa ring nagaganap. So pag hindi na umaabot dun sa gitna ng pagkain mo yung microwave energy, mas hihilaw pa rin yun. Okay? The only reason we're saying that compared to conduction, it doesn't per se heat from the outside in because the heating can occur directly doon sa loob ng food material without having to um, conduct itself from the outermost portion. However, the waves still come from the outer part of the food papaloob, di ba? So we have to understand that it could still mean na may cold point pa rin yung pagkain natin, similar to how we encounter cold points in thermal processing, let's say sa canning. Okay, but of course the behavior is slightly different because we have this. So yun yung importance ng penetration depth. It can allow us to see um, maybe model out further from calculating penetration depth kung gaano um, let's say kalaki kailangan yung food pieces mo para ma-assure yung uniform heating, especially if you're using microwave as a form of thermal inactivation. The last thing we want is a cold point. So we have here a table for the properties of common materials. The reason again why we refrain from using metals in a microwave oven is because of the high degree of reflection. From a practical standpoint, if you've ever tried this, minsan biglang makikita mo na lang may lumiliyab na sa microwave. So we actually, as a kid, nagawa ko to, no? Nag-microwave ako ng barbecue, tapos nandun pa yung foil na nakabalot siya. Maapoy na siya sa loob ng microwave. Buti hindi naman nasira. So of course, because of the reflection being high, konti na lang yung na-absorb, natatransmit, and mababa yung depth. For most, kung mapansin nyo, karamihan ng microwavable containers ay either glass or plastic. Okay, so as you can see here, the degree of reflection and absorption for them are both low, and hence you're not wasting energy heating up the container rather than the food. Okay, and because of that, the degree of transmission is high kasi mababa yung loss mo sa reflection and absorption ng container. And the penetration depth is also high kasi kaya niyang, dahil hindi nga siya na-absorb or nire-reflect, tumatagos kahit makapal pa yung glass mo. Okay? Kasi you want the transmission to be high para mapunta sa food yung energy. In the case of heating water, of course, it's a very high absorption. That's why microwave heating of water, sometimes you do that at home. No, kung isang baso lang ng tubig sa umaga yung iinitin mo, why open up an electric kettle or a kettle for that matter? Just put it in a microwave, set it for maybe 30 seconds or a minute, and then you're good to go. Okay? And because of that, if you're gonna have something with water, ina-absorb ng water yun. Kaya minsan kung meron kang let's say soup or something, medyo uneven yung heating, like the water absorbs most of it, and therefore maybe the other food particles in that soup or whatever are not as heated through kasi ninakaw na ng tubig lahat. Of course, eventually there will be conduction and convection when the water is hotter than the, let's say, solid food particles. But generally, that means low water then has a low penetration depth. And lastly, for ice, so you have low degree of absorption because hindi naman makaka-orient yung molecules mo kung solid siya. And therefore, medyo transparent sa microwave transmission yung ice. And so therefore, the penetration depth is higher for ice. So when you put ice in a microwave, it would heat up the parts na medyo natunaw na. Pero microwaves per se will not make it faster to melt the ice. Well, you can of course try this at home by microwaving ice cubes na dry straight from the freezer. But again, ingat-ingat na rin lang of course if you want to try any of these at home. Especially, I do not recommend microwaving metals or do it at your own risk kung may pambili kayo ng bago microwave. So a sample of using the equation. Again, if we have potatoes and ito yung 2.45 gigahertz yung microwave oven natin. And then we have determined that the potato has epsilon prime and double prime values of 64 and 15 respectively. So we can compute for the tangent delta na angle. And from the frequency, we could calculate the wavelength, which in this case, common naman ng 2.45 megahertz sa microwave. So 0.12 meters or what's that, 12.2 cm is around a bit more than 4 inches. Okay. Alright, so tama ba? A bit more than 4 inches. Alright, so we can calculate for the z based on inputting the givens. And that would give us a z value of 21.22 millimeters. Less than 1 inch ito, no? Kasi 25.4 millimeters ang 1 inch. So that means if you have a potato now as big as your fist, after penetrating 1 inch into the potato, then the remaining energy would be less than 40% na. Okay, and that's why you would probably want to microwave smaller potatoes, no, or maybe cut it in half, and that would dramatically increase the time. Now, of course, as a caveat, no, kapag mas marami kayong nilagay sa microwave at hindi naman nagbabago yung power output niya, then definitely there is a law of energy balance, no. Kailangan niya pa rin mas matagal na time para ma-heat through yung lahat ng patatas na yon. So actually in a microwave, it's better to heat up small amounts of food at a time. Or kung sakali man large amounts of food, try to divide them into smaller sizes and then longer time no yung i-set mo. Okay. Okay, so of course we mostly know about microwave ovens from what we've seen at home, or maybe kung wala kayo sa bahay, minsan nakikita nyo sa mga mini stop pag bumili kayo 7-Eleven, initin nila doon, may preset sila, then they know that their food is ready to be served. Microwave ovens are also used in an industrial capacity wherein if for example mga 800 watts lang yung microwave mo sa bahay, yung sa industry could be anywhere from 5,000 to 100,000 watts of power. Okay, and of course ang isa maganda doon is it could heat up the product in a very short amount of time because you're not relying on the limitations of thermal conductivity or the convective heat transfer coefficient for that matter, no? So of course these are more effective for smaller sizes of food products, and we want of course the products to have high absorption capacity of microwave radiation, so yung mga water-based products and those that are not likely to develop cold points are good options. However, though, you do need to determine the food properties and or chemical and microbiological reactions that could take place during specifically for microwave type of thermal processing. So dito papasok yung physico-chem natin in micro. Ano bang mga changes or may undesirable changes ba kapag microwave heating? Kasi baka naman mamaya kapag gusto mong abutin yung parang thermal death time target mo or log reduction ng microorganisms, baka naman yung food product mo ay nag-degrade na yung quality dahil as we know, the uneven heating and the very fast heating could cause some reactions in your food product na may be undesirable. So by now, baka yung iba sa inyo nag-isip na, no? If ice is essentially transparent to microwaves, then why the heck does every microwave oven have that defrost function? And you may remember maybe from your food microbiology that one of the safest ways to thaw food is through microwaving, which is supposedly faster than other methods. Well, we could do this actually because thawing or yung microwave defrost function works in a different manner. So to do this, they have controlled conditions from which to melt the ice. So essentially, if we can look at the dielectric properties of water, we could see here that the tangent delta for ice is much smaller, and that essentially translates to kapag meron kang ice ay hindi ito masyadong maapektuhan ng microwave. Or when you try to defrost something, since uneven yung pag-melt ng water molecules, ice crystals will remain cold while liquid regions will heat up rapidly. So if you used, let's say, your normal low, medium, high setting ng home microwave oven ninyo to defrost, that's exactly what will happen. Maluluto na yung ibang parts ng food na medyo may tunaw na yung water nila na molecules. Tapos may iwan pa ring crystallized yung parts na may ice crystals until the heat from dun sa mga naluto na part due to conduction and convection will eventually melt them. So what a defrosting function in your microwave oven actually does is a sort of controlled heating through intermittently turning on and off the microwave field. So ang effect nito is dahil hindi continuous yung supply ng energy mo, hindi patuloy na tumataas yung temperature ng parts na tunaw na yung ice. And then it allows, of course, other forms of heat transfer to melt the ice, since the ice will not accept as much energy from the electromagnetic waves, pero yung heat energy galing dun sa katabi nilang natunaw na ay pwedeng mag-transfer through conduction or convection, then yun yung ginagamit. So ngayon nagluto ako uli ng nilaga and I tried microwaving the meat using the defrost function. And even though it was more than half a kilo chunk of meat that was frozen solid despite being in the refrigerator for a few hours, in just 5 minutes or so, it was good as new. I mean, good as ready to cook na siya. Okay? And hindi naman siya naluto. No? Kasi pag pinilit mo ginamit mo yung low, medium, high, para mo na siyang napan binoil or something yung itsura. Okay? So yan. And again, this is achieved in some cases using automated control sensor based on sensors and temperature feedback. Okay, yung mga mas advanced na modelo siguro may ganon. Maybe for low-end models, it's just a fixed intermittent on and off of the microwave field. Alright, balik tayo sa geometric properties. When microwaving food, geometric properties are important. So they've found out that because maximum microwave absorption happens on the surface, there is greater heating in the corners and less at the internal regions kasi yung kanto ay malaki ang surface area to volume ratio, no? So if you look at this box, yung kanto niyan, di ba? And to solve this, you can have a perfectly spherical shape so that medyo even yung heating. However, ang downside naman nun ay meron siyang cold point at the geometric center. So to have a nice compromise, no, we want a large surface area to volume ratio, meaning mga flatter, thinner pieces of food, and at the same time, medyo rounded. So kung makita nyo yung mga microwave containers, pati yung pizza, rounded yung ano niya, yung edges, and then yung mga pockets for containing the food ay rounded din. Not because the materials themselves will absorb much energy, but because of course kung ginawa mong kwadrado to for example, merong parts niyang corn mo na mas maluluto. Okay? Right. So how does food composition affect yung microwave heating? So when you have a higher heat capacity, it can absorb more heat before temperature rise, then obviously mas mabagal yung temperature increase kasi nagpasok ka ng food sa microwave, fixed naman yung rate of power niyan, no? So even if it delivers more energy, you need more energy to raise the temperature by a certain amount. Typically, foods have higher capacity if they have higher moisture content. Uh, so in a way, moisture content affects not just the heat capacity but also the dielectric properties of materials. Okay? Kasi alam nga natin, water is a polar molecule and therefore the more water there is, the more energy ang kayang i-absorb. Okay? Um, when we use low energy microwaves, the high heat capacity of water governs the rate of temperature increase. Whereas kung meron tayong high moisture contents, lower temperature increase nga as mentioned here. And then if you have electrolytes, no, yung mga halimbawa yung high salt content na broth versus plain water, so that would increase the permittivity also of your material. And when you have things like dry porous foods with air pockets, these pockets act as thermal insulators, um, keeping the heated portions hot after heating. So, I know kung na-try nyo na minsan, di ba, yung pag sa labas, uy, hindi naman siya masyadong mainit, pero pagkagat mo, daig pa yung peach mango pie or apple pie, no, na caution feeling hot. Kasi nga, although the air pockets themselves are not as much affected by microwaves, the fact that they are there, kung uminit man yung loob, that heat gets trapped inside. Okay? Kaya yun yung mainit minsan na nakakagat ninyo. Or of course, if there are air pockets, the steam could actually dwell in those air pockets. And when you bite into that, ramdam na ramdam mo yung init niya. Because steam, of course, has a higher temperature than um, water. Other than the previously discussed advantages of microwaves, other advantages include operational safety since meron kang enclosed chamber where the microwaving happens. And of course, you're not exposed to things like a flame or high voltage or something. Of course, it also depends on equipment design. And there are high retention rates for things that are normally degraded by heat, such as certain vitamins, antioxidants, phenols, and carotenoids. In terms of application, so there's a link. I'll leave the uh, reference na to na easily Googleable naman through ResearchGate. Okay. Ilang applications na na-determine nila. Okay. Microwave as pre-treatment or pre-cooking for the following: cereal flours, parboiling of rice, bacon, and dried meats. And for those who love bacon, one thing they found out is that there's less shrinkage in your bacon. So from a selling standpoint, that makes it more appealing kasi pag tinitingnan mo yung bacon, yung size naman tinitingnan mo, hindi um, yung weight niya kasi pwede ka namang guyuin sa 1/4 kilo pero pag niluto mo isang sobrang liit na. For baking, some uses include they studied yung effects sa texture, volume, and crust formation. So probably one of the reasons why hindi pa masyadong uso yung microwave baked na products na doon talaga niluluto, start to finish. The other examples include microwave blanching, such as in vegetables, which is a faster method that's less energy intensive. Because kung mataas yung rate ng pag-absorb ng microwave energy ng food mo, then you're wasting a lot less heat compared to say heating water over a pot and you lose half of the heat to the environment already. Okay, you have precision control over the kung ilang watts yung power output, and you need less water versus steam or hot water blanching. So sometimes I've tried cooking pechay in the microwave pag tinatamad akong mag-boil or mag-steam nito. And yes, from an energy standpoint, it does consume less. Also, of course, we know that microwave can be used for drying because you can remove moisture when the moisture is heated hot enough for it to be vaporized in the material. Definitely, you may need a specific equipment for this that perhaps is equipped with a vacuum system or what to remove the moisture or lower the boiling point, etc. Okay. So yeah, may microwave drying then. Again, if you want to learn more, you could read about it in the reference listed. So Figura and Tessera lists many applications. I've noted some of them here just to see yung wide range na pwede mong paggamitan ng microwaves, either as a food processing technique or using correlation of properties related to microwaves that can be used for a variety of purposes. So you have measuring of dielectric measurements to make a food oil-based sensor, checking the quality of coffee, most likely coffee beans, using the idea of permittivity. So there's also studying the changes in dielectric properties during denaturation. So at least ito, we could know, for example, kung dynamically, paano ba nag-change yung let's say heating mo during denaturation of protein. So similar to what you did sa FS127, yung mga heat penetration of starches. Okay. Application of microwave for thermal inactivation such as pasteurization and looking at the effects on different maybe vegetables like asparagus. You can use modeling to look at the effect of microwave heating in foods and studying factors affecting maybe halimbawa if you choose variables like power output, etc. And yung outcomes mo, pwede mo rin um, gawing dependent variables. Okay? So, parang nga siyang pang thesis no, na title. And then here you combine spectroscopy to characterize meat products. But of course, it's still dependent on microwave properties and moisture sensors based on microwaves. So of course, you can read up on these if you want, but definitely as long as you're creative with what you're gonna do with this specific electromagnetic wave and the food that you have. So marami tayong pwedeng gawin other than just using microwaves to heat food. So you could read the link in this slide if you want to know more about the industrial applications, but basically, of course, there's bacterial inactivation, drying, and there are even industrial non-food applications for microwaves such as curing lumber for drying kasi in case you didn't know, yung mga kahoy na binibili natin ay traditionally sa oven ito iniinit to a certain moisture content bago siya i-further process para ibenta para gawing material for houses and whatnot. Okay, also have applications for pharmaceutical products and coatings and even rubber and plastic, etc. and semiconductor production. So this is to say maraming purposes yung microwaves outside of food. Okay, but again, you can read up on the link na nakapost dito sa slide.